Now, this is A Square Maths Made Easy Academy. Now, I want you to observe this critical question, a situation whereby we have an upstairs or a story building. Now, this is if y is y equal to x raised to power x. Now, the question says find y prime. Another name for y prime is differentiation or derivative or dy dx. Now, I want you to just pay attention. You will understand it. Now, don't forget that this is A Square Maths Made Easy Academy. Do well to subscribe, do well to comment, do well to share, and do well to like. I really love you guys. You are doing great. Now, let's move to this wonderful question. Now, but before we start, I still want you to understand that a question can appear like this: x to power x like this, differentiate. You can still do it. Also to power x here to differentiate. You can still do it. We call it step derivative. This is called a step. You know, a step can look like this, and there is a building, that is a block or a building that is attached to it to weigh it out. So which means the person is moving from here. So it means that they may ask you a particular problems like this to do what? Differentiate. Now, in my real video where I will be unveiling the main class, you'll be able to understand exactly where I'm going through. But let us really observe this question. We can solve it. Are you with me? Now, anytime you have powers of x upon each other, now you're going to apply what we call natural log of both sides, or you naturalize both sides. Now, what do I mean by natural log of both sides? I want you to watch. Now, the first thing you are going to do is to take the log of y and the log of x to power x. So let's go ahead. This is ln y. We call it natural log, ln y. And I will go to the next one and call it ln what? X raised to the power of what? X. Are you with me? Now, do you know there is a law in logarithm that when you have something like this, log a raised to the power of what? X. The first thing is to consider the power, which is x. Are you there? Then you have log what? A remaining. Something like this. Now, in that case, what do we do? I want you to watch. So that we'll be achieving what we call ln what? Y. Then equal to, consider the power. What's the power? X. Then ln what? X. Can you see that this particular question at the right hand side have observed what we call differentiation by product rule? By what? Product rule. Whereby we consider this one as u and consider this one as v. Don't worry, in my main video, you will understand exactly the pattern or the principle or how to solve problems like this. Then I want you to understand this. This is a note that I want you to key in. Now the note is this. Anytime you see ln y, and I want to differentiate it, the word ln means 1 over the number, the variable. And what is a variable? The variable is what? Y. That is the first thing. Are you with me now? Then after that, I will now multiply. Then differentiate the denominator, which is y now. You know, if you differentiate y, it will give you what? 1. Are you with me now? So how? How is it y? 1. I want you to observe. Remember, in differentiation, if I want to differentiate y now, this is invisible what? 1. So I'm going to consider the power first. The power is 1. Are you there? Then I will multiply. Then repeat the question, which is y raised to power of 1. Introduce minus y. The minus 1 is from the general word formula. Then I will now move and say 1 times y will give me y. Then 1 minus 1 will give me what? 0. Can you see by the law of indices, anything raised to the power of 0 is always what? 1. So that is why when you differentiate what? Y, the answer is what? 1. The same thing applicable. If you are asked to differentiate ln x, this ln is called natural what? Log. You can also write it like this, is allowed. Log x what? Exponential. That is another name of identifying what we call ln what? X. So let's differentiate it now. Now I said ln x simply means log x what? Exponential. They are the same. So how do we do it? So it is ln. I told you that ln is 1 over what? That. And that is what? X. Are you with me now? Then after that you multiply. The next thing you are going to do is to differentiate what? X. What will it give you? I've told you before, it will give you 1. Just like what happens to y. At the end, 1 times 1 will give me what? 1 all over what? X. This is exactly how to differentiate a natural what? Log. We call it natural log or log exponential or ln x. Now can we move? We are watch. Now let's differentiate now. Haven't take the natural log of both sides. Now if you differentiate ln y, I have told you the word ln means 1 over y. Are you there? Then you now multiply. Then differentiate the y again. And if you differentiate y, it will give you what? 1. Then we move over to the left, to the right, I mean to say. Now what happens to the right? We use what we call differentiation by what? Product rule. Do you know why? This is a function of each of. This is another function of what? Each of. Both of them is multiplying. And because they are multiplying, the law is that use product rule formula. Now how do we achieve that? Watch. Now, to finish that, I still want to take you back to the left-hand side. Now, the law is that once you have finished differentiating what? Y, please remember to put dy over what? Dx. Somebody may ask me, what is the reason of introducing dy dx? The reason is because y is always a function of what? X. Am I communicating now? So that is why if you are differentiating y with respect to x, remember that the result of this under derivative will give you dy all over what? Dx. Then if you are differentiating x alone, the answer is what? 1. Can you observe this now? So the law is this. Anytime you are differentiating y, remember to put dy dx. Am I communicating? The reason is because y is a function of what? X. And if y is a function of x, it means that y is called what? Is called what? Look up. Y is called the codomain. The what? Codomain of a function, which I will still explain. Yx is called the what? Domain. Is called the what? Domain. Are you with me now? So invariably, I can still consider y as what? Range, which I will still what? Explain. So these are why reason whenever you differentiate y, remember to put dy all over what? Dx. And that is exactly what I imputed here. Then let's move. This is now equal to, are you there? Now, how do we differentiate the right hand side? I said use product rule. It has a format. Listen. The first thing you are going to do is to put the value of u constant. What's the value of u? The value of u is x. Are you with me now? And differentiate what? V. And V is ln what? X. I have told you, anytime you differentiating ln, this is multiplication, right? Remember to call it 1 over what? X. Then you multiply and differentiate that x to give you what? 1. We are done with the expression. Now, after that, the next thing you are going to introduce under product is what? Addition. Then vice versa. We now put what? Ln x constant, which is v. I will now say ln what? X. Are you with me? Close the brackets. And differentiate what? U. And you know that the value of u is what? X. I have taught you how to differentiate x. What is the answer? 1. Something is about to happen here. Then let's go. 1 times 1 will give you 1. Then all over what? Y. Then put dy all over what? Dx. Now, if that is the case, can we say this is now equal to? Now, watch. X down here, we cancel x up here. So what remains here is 1 times 1, which will give you 1. Then plus ln x times 1 will give me ln what? X. Are you with me? Then what is my target? Is to make dy dx subject of the formula. Then what do? I will multiply both left and right by what? Y. Are you with me now? So let's go. So I will now say 1 over y times what? Y. Then dy all over what? Dx. That is now equal to, this is y, right? Open bracket. 1 plus what? Ln what? X. Close the bracket. You can now agree with me that we have made the y dx subject of the word formula. Y down here, we cancel y up here. So dy dx, 1 times dy dx will give me dy all over what? Dx, which is the same thing as what? Y prime. Are you with me now? Then equal to, then do we know the value of y? Yes. Look at it from the question. Y is x raised to the power of 3. I will now put x raised to the power of what? X, sorry. I mean x raised to the power of what? X, which is the value of what? Y. Then open the bracket. What do you have again? 1 plus what? I now have ln what? X. So gentlemen and ladies, this is the final what? Answer. So see you in my next video. Don't forget to share it, subscribe, then comment on the comment section and like. See you in another aspect of what? Differentiation. This is A Square, Maths Made Easy Academy. Bye.